Alright, so this is a video for assignment 12. These are supplemental problems for changes that were made in the assignment 12. So let's look at number 4 first here. We want to look at the denominators. Notice you got an x minus 2 and an x plus 2. We have to treat those as two different numbers. I call them algebraic factors. And so our LCD is going to consist of both of those. And we know we want to clear fractions, and we do that by multiplying both sides of the equation by the LCD. So when we do that, each of the terms gets multiplied by our LCD. So notice on the left we've got I didn't mention, we do have some restricted values here. Notice that if x were 2, in this denominator here, x minus 2, you'd have 0. 2 minus 2 would be 0, so we would be undefined. So that would be a restricted value, and of course negative 2 would be a problem in the other denominator here. So those are our restricted values. If when we're done we get a solution of 2 or negative 2, we got to throw it out. So let's go ahead and multiply both sides by our LCD. So every term ends up getting multiplied by the LCD. So on the left there, when we multiply by 5 over x minus 2, notice the x minus 2's are going to cancel, and you're left with 5 times x plus 2. In the middle there, 6 over x plus 2, here you're going to have the x plus 2's canceling, and you'll be left with 6 times x minus 2. Now on the other side, you also have to multiply the 2 by x plus 2 times x minus 2. So let's go ahead and why don't we FOIL that off to the side over here. So I'm going to go ahead and multiply x times x is x squared, x times a minus 2 is a minus 2x. We're going to get a 2x as our middle or for our inner product, and a minus 4 for the last product. So notice you have some like terms here. They're opposites, and we get x squared minus 4. And we know anytime we multiply two binomials and we have the same numbers, in this case x and 2, with opposite signs, we're going to end up with a difference of squares. So let's go ahead and plug that in. So x plus 2 times x minus 2 is x squared minus 4. And so we got some simplifying to do. So let's distribute. We get 5x plus 10 for that first one there, and then we're going to get 6x minus 12. And on the other side, 2x squared minus 8. So we still have some simplifying to do, so let's combine our 5x and 6x. You get 11x. And the 10 and the minus 12, that's going to give you negative 2. And let me just rewrite the right side. So this is a quadratic equation. So we're going to want to get 0 on one side and everything else on the other. So I'm going to subtract 11x and add 2 to both sides. And that's going to get me 0 on the left. Now on the other side, just be careful there. You only have one x squared term, so you'll just bring that down, the 2x squared. You have a minus 11x. There's no other like terms for that one. But the negative 8 and 2, that's going to give you a minus 6. So this is a trinomial. And so we're going to use the AC method. We're going to try to factor this. So a times c, we're going to get negative 12 for that. Of course, our b term is negative 11. So as you look for two numbers that multiply to negative 12 and add up to negative 11, you're going to end up with 1 and negative 12. Notice 1 times negative 12 is negative 12, and 1 plus negative 12 gives you negative 11. So let's go ahead and split our b term, and we'll factor by grouping here. We're going to get 2x squared plus x minus 12x minus 6. And I'll worry about the equation later. For now, I just want to factor this by grouping, so we can factor out a x here times 2x plus 1, and then when we factor here, we're expecting to get another 2x plus 1, assuming we've done our work correctly on the previous part. So to get that minus 12x there, we're going to need to multiply by minus 6. And notice negative 6 times 1 will also give you the minus 6 here. Alright, so we're going to end up getting 2x plus 1 times x minus 6. And so let's go ahead and set each of our factors equal to 0. And so let's see, 2x plus 1 equals 0. Let's subtract 1 on both sides, and you get 2x equals negative 1. And then we would divide by 2, and we'd get negative a half. And then on the other side, with x minus 6 equals 0, we'll just want to add 6 to both sides. We get x equals 6. And so those are our two answers, negative 1/2 and 6. And notice neither of those was a restricted value, and so we're good on that. Alright, let's look at number 12. It says there's one square that has the same numerical value for its area and perimeter. Determine the length of one of its sides. Well, first of all, we should probably make a square, and we know that, well, why don't we call one of the sides x. In fact, all the sides would have a length of x since it's a square. So we know the area of a rectangle is length times width. In this case, it'd be x times x, or x squared. What about perimeter? We know perimeter, we add up the four sides. So we'd have x plus x plus x plus x. That's just going to be 4x. So if our area equals our perimeter, then we can say x squared is equal to 4x. And we actually, this problem is actually on the review earlier, not in the video here, but on the actual review that you did. You should have subtracted 4x on both sides. And then you could factor out an x times x minus 4. So we're just factoring out a GCF here. And then we set each of our factors equal to 0. And if we add 4 to both sides, we'll get x equals 4. So we have, now keep in mind, x equals 0 is a solution to this equation. But we're not going to have a square with a side of 0. So 4 is our only answer here. They didn't tell us units. It's 4 whatever. Could be 4 feet, 4 inches, depends on the problem. All right, let's move on. So here we're going to solve by completing the square. So if you look at number 13, we know the first step is to get the x squared term and the x term by itself. And notice that's already here. That's already done. So we want to complete the square next. Or I should say, well, we call it completing the square, but basically we want to create a perfect square trinomial. And so what we're going to do is rewrite this like that. So we're going to add something on the left side to make that a perfect square trinomial that we can write as a perfect square. So we had done this, and we found that there's a pattern. So we look at our x term, we got a negative 6 there. We're going to divide that by 2. And we're going to square that number. So that'll be negative 3 squared. And so we're going to add 9 there. Of course, if we add 9 to the left, we're going to add 9 to the right. So that's how we complete the square. As long as we have a 1x squared, we can do that with our x term to figure out what the third term is going to be. So let's go ahead and write this as a perfect square. We know it's going to be x minus, or it'll be x, and then you take half of negative 6. That's what's going to go in the parentheses. So x minus 3 squared is equal to that perfect square trinomial. If you actually FOILed 2 of these x minus 3's out, you would see that it's equal to what we have above. But anyway, now we can set that equal to 11. And so now we have a quadratic equation that we can solve by taking the square root of both sides. So that's what we're going to do next. So don't forget, when you do that, you got to do that plus or minus thing. We're expecting to get 2 answers, and that's how we end up getting it. So when we take the square root of x minus 3 squared, that's going to cancel the square. A square root and squaring are opposites, so we're going to end up with x minus 3. And of course we have plus or minus square root 11 on the other side. So to get x by itself, we're going to add 3 to both sides. And let's put that 3 in front of the square root of 11 between, well, the plus or minus will be in between. So our final answer is x equals 3 plus or minus the square root of 11. That means there's two answers, 3 plus the square root of 11 and 3 minus the square root of 11. And it's perfectly fine to write it this way. All right, let's look at number 14. So notice this time we don't have just the x squared and the x term by itself. We need to get rid of that plus 6. So let's go ahead and do that by subtracting 6 on both sides. So now it's in the form we need, and we're ready to complete the square. So we have to figure out what to add here. So we'll take half of 4 and square that. That's going to be 2 squared, which is going to give us 4. So you should be adding 4 to both sides. We know we always, whatever we do to one side, we'll do to the other. So we're going to end up with, so again, half of 4 was 2. We're going to have x plus 2 squared when we write this left side in perfect squared form. On the other side, we're going to have negative 2. So now we can go ahead and take the square root of both sides. Again, don't forget your plus or minus. We're going to get x plus 2 on the left is equal to plus or minus, and notice we can pull out an I here, or we can write that as the square root of negative 1 times square root of 2, which is I square root of 2. So plus or minus I square root of 2. Only thing left to do here is to subtract 2 on both sides to get x by itself. You're going to get x equals negative 2 plus or minus I square root of 2. All right, let's move on to number 16. Now here they're telling us to use the square root property. So what we want to do is get this squared part, x plus 3 quantity squared, all by itself. So let's get rid of that 6 by subtracting 6 on both sides. We're going to get x plus 3 squared is equal to 64. And so let's go ahead and take the square root of both sides. So we're going to get x plus 3 on the left and plus or minus 8 on the right. So to get x by itself, we're going to subtract 3 on both sides. So you're going to end up with x equals negative 3 plus or minus 8. Now remember, like in the last two problems that we did, like here and here, what we had did not have like terms. We had an I term here and an integer here. You can't combine those together. Here you had a radical term and an integer, and you can't add those together. They're not like terms. But that's not the case with the problem we're working on right now. Let me get rid of all that. We have negative 3 plus 8. We can add that together and we get 5. And our other answer will be negative 3 minus 8. And so there we're going to get negative 11. So our answers are negative 11 and 5. All right. On number 20, so here it says solve by factoring, and this is what we call quadratic in form. Normally we'd have an x squared instead of x to the 4th, and instead of that x squared we'd have an x there. At least that's what we've had with quadratic equations. So we're going to treat this one just like that with one minor adjustment. So we got to do the AC method. We'll look for two numbers that multiply to negative 7 that add to negative 6. So there's only one possibility with 7, 1 times 7. And we're going to want to make the bigger number negative so that when we add we get negative 6. So 1 times negative 7 is negative 7, and 1 plus negative 7 does give you negative 6. So we don't have to split our b term and factor by grouping because we do have a 1 x to the 4th. So we can just go ahead and plug these numbers in. Actually, you know what, on this I actually did go or do the long way, so let me just go ahead and do that. So we're going to write, we are going to split our b term, and we're going to write it as x squared minus 7x squared. So notice when we split our b term, we're going to break our x squared term into two x squared terms. So that's a little bit different, but that makes sense because those do add up to negative 6x squared. And let's bring that 7 down, and then let's factor by grouping. So we can factor out an x squared there, times x squared plus 1. And so when we factor here, we expect to get an x squared plus 1. And notice to get that negative 7x squared there, we're going to have to multiply by negative 7. So we're going to end up with x squared plus 1 times x squared minus 7. And that's equal to 0. So we have two factors equal to 0. We'll want to set each factor equal to 0. And we'll use the square root method to solve. So on the first one here, let's subtract 1 on both sides. And then we'll take the square root. And you're going to get plus or minus I. And then on the other one, we're going to want to add 7 to both sides. We'll get x squared equals 7. And when we take the square root of both sides, we get x equals plus or minus square root of 7. So those are our 4 answers. Notice each of these has 2. And that's how we do that. Now again, this part right here is actually optional, because if you look at the numbers we got, you could have just plugged them in right here and taken the shortcut, again, because this is actually a 1. So you can do it either way, but if you want, you can skip those 2 steps. Let's move on to the next one. And actually, I'm just going to get you started on this one because this is a graded one. So notice our GC or our LCD is going to include an x minus 2 and an x minus 1. And so notice x can't be 2 or 1. Oops, I said that wrong. Or that should be positive. Let's fix that. Alright, so let's go ahead and multiply, or you're going to need to multiply each of these terms by x minus 2 times x minus 1. And this problem is going to be a lot like number 4, which I did earlier in this video. So anyway, that should at least get you off to a good start. And that's it for this video.